All right, guys, section 5.5, we're going to talk about performing function operations. There's two parts to this. We're only going to do the first part, which is combining functions. What does it mean to combine something? Put it what? If you combine things, you put it together, right? So there's also something called compositions of functions. We're not going to get into that right now. We're just going to get into the combining. So literally, what we're going to be doing is adding, subtracting, multiplying, dividing like terms, okay? So this is, have you guys seen this before, the way that this looks? If you are adding two functions together, it can be written like this. Do you see where it says f plus g? The way we read that is f plus g of x. Or it can be written separated where it says f of x plus g of x. And the way that that would look is you would take the f function and the g function. Do you see how like this is the f function, this is the g function, and you're combining them, you add them, you put together like terms. So the same thing can be said for subtraction, where you take the first function, subtract it from the second, all that good stuff. Multiplying, you see they're written next to each other, or with the multiplication symbol, and then dividing one on top of the other. What you have to be careful with is they're going to ask you at some point to state domain. So there's a couple times we'll have domain restrictions. First of all, if you're going to get a real number, if you're going to have a real answer, and you have a square root, in order to get a real number, tell me something about that number underneath the radical. It needs to be what? Positive, right? It's got to be 0 or bigger, because what happens if I have a negative underneath the square root? It's imaginary. So that would be a domain restriction. Another thing that's a domain restriction is a denominator. What do we know about a fraction? The denominator can never, ever, ever, ever be what? What can you never divide by? 0. So there's going to be times when we have to look and say, okay, wait, you know what? There is some restrictions. We cannot use certain numbers because it'll make either my function imaginary or it'll make it undefined. So that's what we got to look at. So we're going to go through a few examples, and then at the end of this, I have like 17 extra examples. It is purely for your extra practice. You guys have a homework assignment. It's maybe 8 or 10 questions. But I have extra practice at the end of these notes in case you guys want a little extra practice. Now, I do want you to see something, all right? There are times when you're going to be given a question and it says f plus g of x. Or when it says something like this, f plus g of 4. Does anybody know the difference between those two things? It's not, I see what you're saying, that you'd have to multiply, but that's not multiplying. What is 4 replacing here? The x. You are going to have questions where sometimes you're answering it in terms of x, and sometimes you're answering it in terms of a number. So if you have a problem that looks like this, all you're doing is combining like terms. You're not going to get a number answer. You're going to get something with x's in it. If you have something like this, they're telling you to replace all the x's with what number? 4, okay? So we're going to do these a couple different ways because you're going to have some on your quiz that are in terms of x and some that are in terms of a number. So let's evaluate this. What do they want us to do with the f and the g function? We're adding them, right? So this is f plus g of x. If it's in terms of x, that means what should you have in your answer? One number answer or x's? X's, okay? So your f function is 3 square root of x plus, what is the g function? Negative 10 square root of x. Can I combine these two? Do they have the same last name? Do they have like terms? Yes, I have 3 and a negative 10. If I say 3 plus negative 10, what does that give me? Negative 7. So you would answer this question. You would say f plus g of x equals negative 7 times the square root of x. That's leaving your answer in terms of x. Now, if the question tells you here to evaluate when x is 4, what do you think I do with 4? You're going to plug it in. So f plus g of 4. I'm going to say -7, and instead of x, I'm going to write a 4. Can we simplify this? Yes. What's the square root of 4? 2. So -7 times 2 is, what is it? -7 times 2 is -14. Do you see the two different answers here? When you have a number that you are plugging in for x, you have a numerical answer. If you have an x here, it's saying, hey guys, leave your answer in terms of x. Now it asks you to state the domain. Do we have any domain restrictions? Do I have a problem in my original, do I have an issue? Where is your x? It's underneath what? Where is your x value? It's underneath the square root. So can I use any number in the world that I want to? No, I can't use what kind of numbers? I can use all the positive ones I want, right? I can use 0, but can I use negative numbers? So your domain, what you would say is I have to use all number. Have you guys done interval notation yet? Like if I do this, do you know what this means? All right, so you want to use all the numbers that are greater than or equal to 0. You cannot use anything less than 0 because what happens? Then anything underneath the radical is going to become imaginary. Does that make sense? Do you guys see that? Okay, let's look at the next one. Just do a couple of these. Says, here's my f function. Here's my g. And what do they want me to do with these two first? They want to subtract it. So it's f minus g of x. That means my answer is going to be one singular number, or it's going to be a bunch of x's and stuff. Am I plugging in a number right now, or am I just leaving everything in terms of x? Everything in terms of x. Guys, when you have subtraction, you got to be real careful because order matters here. My f function, I'm going to leave it in a parenthesis. I'm going to say 3x cubed minus 2x squared plus 5. I'm going to put a minus sign, and then I have my g. So it's x cubed minus 3x squared plus 4x minus 2. Before I can combine like terms, what do I have to do with that minus sign in the middle? I have to distribute it. I have to distribute this negative sign to everything behind. What does that end up doing to all the signs? They're all going to change. So I'm going to change this to a plus, change that to a minus, change that to a plus, change that to a minus, change that to a plus. And now can we just go through and combine like terms? Yes. So you would say f minus g of x. When I take the f function and I subtract the g from it, and we combine our like terms, what is 3x cubed minus 1x cubed? Okay, 2x cubed, good. What's a negative 2x? That's negative, right? Negative 2x squared plus 3x squared. Plus x squared, good. Now what? Minus 4x, good. And then what? Plus 7. That is f minus g of x. Now the next question says, what is f minus g of what number? Negative 2. So what do I do now? I'm going to plug in a negative 2 where? For every x that I see. So I'm just going to say 2 times negative 2 cubed plus negative 2 squared minus 4 times negative 2 plus 7. You guys agree? You understand that? So now let's just simplify. What do we do first? Exponents? So what is negative 2 to the third power? It is negative 8. So I have 2 times negative 8 plus, good. What's negative 2 squared? 4, good. And then I have a negative 4 times a negative 2 gives me plus 8, and then plus 7. So yes, negative 16 plus 4 plus 8 plus 7. We go left to right. What's negative 16 plus 4? Negative 12, right? Plus 8 is negative 4. And then negative 4 plus 7 is 3. So f minus g of negative 2. What you're saying is when I subtract these two and I plug in negative 2, what is my answer? 3. So you got to be careful at how the question is asked. Sometimes it'll be asked to leave your answer in terms of x. That's when a little x is in the parenthesis behind it. Or sometimes they'll ask you to evaluate it when you plug in a number. So you just have to be careful and see what they're asking. Anybody have any questions? Okay. All right. It said to state the domain. Do I have any domain restrictions? Do I have any numbers I'm not allowed to use? Can I plug in any negative number I want and still get out an answer? Yes. Can I plug in any positive number I want and still get an answer? Yes. So no domain. Let's look at the next one. Multiplying two functions. All right. When we multiply two functions. Oh, you know what? Let me hold on restrictions there. You can use all real numbers. All right. What are they asking us to do here in example 3? Multiply. They're asking us to multiply the two functions together. So first we're going to keep it in terms of x. So f times g of x. Well, what is my f function? X squared times the square root of x. Now we're like, what can we do here? What's another way I can write the square root of x with a different exponent? X to the what power? To the what? 1/2. Perfect. X to the 1/2. Do I now have bases that are the same? Yes. All right. So when you have bases that are the same, what do you do to the exponents? You add them. So this is 2 over 1 plus 1 over 2. What's the common denominator between 2 and 1? 2. So if I make this a 2, multiply the bottom by 2, then I have to multiply the top by what? 2. What's 2 times 2? 4. All right, so when I simplify this, this becomes x to the what? 5 over 2. X to the 5/2. God bless you. If you would like to rewrite it as the square root of x to the 5th power, you can. You don't have to. You can leave it either way. So that would be leaving your answer in terms of what? In terms of x, right? But if they ask me for what is f times g of 9, what do they want me to do? Plug in 9. So you can say 9 to the 5/2 power. Or you can say the square root of 9 to the 5th power. You get the same answer. What is the square root of 9? 3. And then you would raise it to the 5th power. Because remember, your index becomes your root. So 3 to the 5th power. 3 times 3 is 9. 3 times 3 times 3 times 3 times 3. So 3 times 3 is 9, right? 3 times 3 is 9. 9 times 9 is 81. So it's 81 times 3? 243. So your f of g of 9 is 243. Notice when you plug in a number, you get out a number answer. Are there any domain restrictions? Do I have a variable underneath the square root, or do I have a variable in a denominator? Where's my variable? Do I have a variable underneath the square root? Yes. So that means I can't use what kind of numbers? I can't use negative ones. So I have to use only values of x that are greater than or equal to 0. You have to state the domain, because think about it, guys. You can't plug in a negative 3. It'll make your problem imaginary. So you got to be careful with that. All right, let's look at this one. This is asking us to do what? Bunch of things here. What's this asking us to do? Add them together, subtract them, and then plug in what number? 8. Okay, so first let's add these two functions, f plus g, and leave it in terms of x. What is the f function? Negative 2x to the 2/3 power? Plus, what's your g function? 7 times x to the 2/3. Are those like terms? Yeah, they both have the same variable, same exponent. So if I have -2 plus 7, what does that give me? What is it? Yep, 5x to the 2/3 power. That is your f plus g of x. You left your answer in terms of x. Now the second question that has to do with the addition is asking you to evaluate with what number? 8. So you have 5 times 8 to the 2/3 power. So let's think about what that means. Sometimes those exponents kind of get a little confusing. This is 5 times, how could I rewrite 8 to the 2/3 power? The cube root of 8, what? Perfect. So let's evaluate that first. What number times itself 3 times gives me 8? Okay, so this really is 2 to the 2nd power. So then I have 5 times, what's 2 squared? 4, all right. So when I add my two functions together and I plug in 8, what do I get out? The number what? 20. Everybody okay? Everybody see that? Now when I do the same thing and I subtract them, should I get the same answers? No, because you're not adding them together, you're subtracting. So let's do that over here. We'll say f minus g of x. We'll leave it in terms of x first. So my f function is -2x to the 2/3 power minus 7x to the 2/3 power. What does that give me? What's a -2 and a -7? -9, good. So -9x to the 2/3. That is leaving your answer in terms of x. You have an x in your answer. So now we're going to do the exact same thing. We're going to say f minus g, but we're going to plug in what number do they want? 8. So let's do it. -9 times 8 to the 2/3 power. Sure. So I have -9 times, what's another way I can write this? I can write this as the cube root of 8 squared, right? So -9 times, what number times itself 3 times gives me 8? 2, and 2 squared is, what's 2 squared? So then -9 times 4 is? What kind of 36? Perfect. Now notice, by changing just one little thing, a plus to a minus, it changes both answers when you leave it in terms of x and when you leave it in terms of a number. Do I have any domain restrictions here? Why do you say no? That's a very good question, very good answer. Why is it no? I see a radical. We can use all real numbers. Did we take the square root of a number? No, what did we take? What did we take? What root did we take here? The cube root. Can you have a negative? Can you take the cube root of a negative? Yes. So you're only going to have a domain restriction when you have a radical when it's an even root, like a square root, 4th root, something like that. All right, you guys are doing good. All right, now we look at this, we're like, oh, now we have to divide, right? What can a denominator never, ever, ever, ever be? 0, right? You're going to have a domain restriction when you're doing this. So you're going to take your f function and divide it by the g and leave it in terms of x. That's what we're going to do first. So my f function is 6x divided by the g function, which is x to the 3/4 power. Some of you are like, oh, I don't know what to do here, guys. Well, think about it. Do you have the same bases? Right? And you're doing what? Dividing? So when you have the same bases, what do you do to the exponents? You subtract. So this is 6x to the 1 minus 3/4. What's another way I can write the whole number 1? 4/4. You guys agree? So if I have 4/4 minus 3/4, this gives me 6x to the which power? To the 1/4. Okay, 6x to the 1/4 power. God bless. Is it okay to leave it like that? Sure. It's okay. What's another way I could write it? The fourth root of x. Perfect, guys. Very good. So that is in terms of x, correct? Well, what if they want us to find f divided by g of what number did they say? 16? Okay, so I have 6 times the fourth root of 16. What number times itself 4 times gives me 16? 2. So I have 6 times 2 is 12. Notice how when you plug a number in, what do you get out as an answer? A number, right? What can x not be here? Cannot be 0. Good. What else can it not be? Can it be negative? No. So in this case, guys, your domain is going to be x has to be greater than 0. Not greater than or equal to, because it can't be 0. Why can't it be 0? Because 0 is where? In the denominator. That's the hardest part of this, is the domain thing. That's why I want you guys to practice a little more. You guys are all good at combining like terms and adding and subtracting. You're fine with that. It's the domain stuff that could be hard. All right, let's do one more, and then I'll let you guys get started on your homework. F divided by g. We're going to leave it in terms of x first, and then we'll go ahead and plug in a number. Now think of it, y'all. If you've got to pay attention to order. If you're multiplying or you're adding, it doesn't matter if you say f plus g or g plus f, or g times f or f times g. That doesn't matter. But subtraction makes a big difference, and so does division. So just make sure you're paying attention. Your f function is 3x. Your g function is x to the 1/5. This is the exact same kind of problem we just did. You're dividing bases that are the same. So what do you do with the exponents? You subtract. So this is 3x to the 1 minus 1/5. What's another way I can write the whole number 1? 5 over 5. Good. So this becomes 3 times x to the 4/5 power. Correct? All right. What's another way we could write that? 3 times the 5th root of x to the 4th. You guys agree? Okay. So that's in terms of x. Now, what do they want us to substitute in? What number? 32. So I have 3 times the 5th root of 32 raised to the 4th power. Well, let's evaluate that. What number times itself 5 times gives me 32? 2. Good. And then we have to raise that to the 4th power. So 2 to the 4th power is 2 times 2 is 4, times 2 is 8, times 2 is... Good. 3 times 16 gives me 48. Let me just finish this one thing. Think about domain. Do I have any domain restrictions here? Do I have a variable underneath a radical? Yes. But it's an odd root. Can you take the odd root of a negative number? Yeah, absolutely. So you don't have a domain problem there. But where is the domain issue? Your denominator cannot be what number? Cannot be 0. So what's the only number in the world that I'm not allowed to use in this problem? X cannot be 0. It can be any positive number. It can be any negative number. But it cannot be 0. You guys see that? All right. So look what I did here. You do not have to do these. Okay, you guys have a homework assignment that I would like you to work on. I put these here for extra practice. I thought tomorrow, after you're done with the quiz review, if you wanted a little extra practice on this, you could practice with it, and I can go over it on Friday. If you don't want to, no big deal. But I put a bunch here. Look at the first 1, 2, 3, 4, 5, 6, 7, 8. Look at the first 8. What kind of an answer are you going to get? A pretty number or a bunch of X's? For the first 8 problems. Are you going to have is your answer going to be a number answer? Or is it going to be in terms of x's? It's going to be a number, because what are they telling you to do? They're telling you to combine the function. Actually, cross off 8. You're not going to have to do 8. They're telling you to combine the function and then plug in a number. You can do this one of 2 ways. If you wanted to put, like, for let's look at number 2. If you wanted to say, okay, in my h function, I'm going to say 3 times 10 plus 3 plus in my g, negative 4 times 10 plus 1. Do you see how I kept them separate and I put the number in? Oh, the internet's not working right now. Okay, please hold. So I just went ahead and plugged the 10 into the h function and then to the g, and then I'm going to add that together. You're welcome to do that if you wanted to. This is 30 plus 3, right? Plus negative 40 plus 1. So then this becomes 33 minus what? 39? So then your answer here would be negative 6. You would get the same answer if you added them together first. 3x plus 3 plus negative 4x plus 1. Combine like terms. 3x and a negative 4x is negative x. And then 3 plus 1 is 4. And then plugged in 10. You get the same thing, right? You get negative 10 plus 4, which is negative 6. If you want to combine the functions first and then plug the number in, you can. If you want to plug, you should get a next answer. Everybody with me? Okay.